Hi, in this presentation, I will be providing some information on how to use machine learning for music information retrieval. The article from which I grab most of the information is written by Bo Xiao and Ding Wang. I am the presenter Vijay Shankar Natarajan. If you're not familiar with my English accent, I have provided the link of a transcript for this presentation in the description of this video. So, what can you learn here? You can learn how to use machine learning to categorize music, specifically categorizing based on genre, emotion, and style. Finally, we can see how music recommendation algorithm works and few places where they implemented it. Before categorizing music, we need the features of the music which can be extracted from the audio signals, like it's loud or having a lot of beats and so on. Specifically, for identifying the style of music, this article uses the lyrics, which we will see in this presentation in a few minutes. Three algorithms can be used to extract the features from music. They are MFCC, STFT, and DWCH. The Mel frequency substral coefficients algorithm, which is the one used in this article, has 7 stages. As you can see in this figure, in the pre-emphasis phase, higher frequencies are emphasized by increasing the energy of the signal. In the windowing phase, the frequencies are segmented and the voice signal is divided into frames. Finally, at the end of this phase, we get the desired features of the music file. Well, for the lyrics, there are several techniques like bag of words, part of speech, lexical features, and orthographic features. Basically, all these techniques compute the TF-IDF measure for each word and selects top 200 words as the features. So how do we categorize music by genre? Once we have the mapping between the types of audio signals and predefined music types, categorizing into genre becomes a classification problem. Any of these classification algorithms can be used to classify this song has this particular audio feature and belongs to this genre. For example, in k nearest neighbors algorithm, it compares the input audio with its k neighbors and determines the genre of the input. This graph shows their experiment with 100 files per genre, each of length 30 seconds. As you can see, the accuracy is satisfactory. The emotion detection is basically classifying the song into cheerful, depressing, relaxing, and so on. However, in his paper, studied on the relation between musical sound and its impact on emotion of the listener. Using his results, our problem reduces to multi-label classification problem. That is, every song can be labeled as cheerful as well as exciting. One of the techniques used is support vector machines. In this experiment, they took 235 instrumental jazz tracks and two subjects were made to tag these songs, and the comparison of their result with this approach was very good. For identifying the style, we use a clustering algorithm which is based on an expectation maximization algorithm. Consider this graph where artists with three related styles like rock, jazz are linked. The algorithm goes like this. Consider three artists having maximum neighbors. Now these three with all of their neighbors form one cluster. Similarly, we can form the other clusters and all the unclustered nodes make a separate cluster. In this diagram, you can consider Fleetwood Mac, Utopia, and Yes. They are the ones having most of the neighbors, and all the neighbors of these three are formed into one cluster. The same method is followed for the others, and the Moody Blues, Indigo Girls, which are the ones which are not clustered, forms a separate cluster. And music recommendation, as you can see, most of these are implemented now online. I remember last.fm, Goomba, Pandora, and many things. So how do they find what music you like? There are three methods for identifying this. One is collaborative filtering, where similar users like you are detected and the songs they have listened which you have not listened are suggested to you. The next method is content based, meaning the recommended music based on the features of the audio signals in the songs you have heard. In this paper, they combine both these techniques and form a song graph. Consider each node in this graph to be a song. The weights on the edges of these graphs are level of relevance, meaning 1 is less related to 3 and 1 is more related to 2. Now, to find the list of recommended music, just pick an arbitrary node. Assume that this is the song which you heard. Find the shortest path from this node to all the nodes. We can use repeated Dijkstra or Floyd-Warshall or even dynamic programming. Each shortest path we find will have the cost of the travel, right? That is, the path from 1 to 5 will cost 1 plus 6 is 7. The similar way, the list of nodes ordered by the cost will be our recommendation list. Thank you so much for watching this video with patience.